Our sixth lecture video on rotational motion will cover rotational power in the English or standard system. If time is given in seconds in the problem, we can use the equation power is equal to torque times 2 pi revolutions divided by time. If the time is given in minutes instead, rotational power is equal to the torque in foot-pounds times the number of revolutions per minute, or RPM, times 0.105 minutes per revolution seconds. 0.105 minutes per revolution seconds is essentially a unit conversion within the problem. This is the same thing as 2 pi times 1 minute divided by 60 seconds. The reason that there are such odd units in the equation are so that the units cancel. In both equations, the units for rotational power are foot-pounds per second. The last slide showed us the equations we can use to solve for rotational power in units of foot-pounds per second. However, typically when we talk about rotational power in the English or standard system, we have units of horsepower. If we want rotational power in horsepower, we need to take the power in foot-pounds per second and multiply that by the conversion that 1 horsepower is equal to 550 foot-pounds per second. In this manner, units of foot-pounds per second will cancel out, and we are left with only units of horsepower. Now that we understand how to find power in the English system, let's take a look at an example. What horsepower is developed by a different racing engine that produces 495 pound-feet of torque at 6,650 revolutions per minute? First, we will write down everything we know. The torque is 495 foot-pounds. The angular velocity omega is 6,650 revolutions per minute. And we are trying to find power P. The basic equation that we can use to find power in the English system is that power is equal to the torque times the angular velocity times the constant 0.105 minutes per revolution seconds. Since this is already written in terms of power, we can directly substitute into the basic equation. Power is equal to 495 pound-feet times 6,650 revolutions per minute times 0.105 minutes per revolution seconds. Multiplying, we see that the power developed by this engine is 346,000 pound-feet per second. However, the question specifically asks what horsepower is developed, and we want to find the power in horsepower instead. Power in horsepower can be found by taking the power in foot-pounds per second and multiplying that by the conversion factor. 1 horsepower is equal to 550 foot-pounds per second. We can substitute our answer from the previous slide to see that the power in horsepower is equal to 346,000 pound-feet per second times 1 horsepower divided by 550 foot-pounds per second. After multiplying, we see that this racing engine develops 629 horsepower. This concludes our discussion on rotational power in the English system.